Okay, here we have a question about nuclear density. This is a HL level question. I'm just reminding myself there for a second. So please, SL, feel free to watch. However, you do not need to expect to do any question like this in your paper. Okay, so we're looking at the variation of density with the nucleon number A. Now again, if I were to, I think I'm going to have to develop a series of sounds for questions which are really important and which come up again and again, a klaxon of types, because this is one I've seen many times. Once you know the answer, you know it, and hopefully you hope that it comes up because it's a really good question. Let's try and work out from first principles. We're going to go for density as mass over volume. And we're going to be aware of the fact that for any nucleus with A nucleons, each of those nucleons has pretty much the same mass. We'll just call that mass U, that's the atomic mass unit. So 1.6 something or other times 10 to the minus 27. We're going to just say all nucleons are the same. So our mass is A times U. Simple enough so far. We're then going to use the volume. Okay, we're going to assume that we're dealing with a sphere. Again, maybe a silly approximation, especially when you've got 2 or 3 nucleons, but roughly we're going to model our nuclei as spheres. So 4 over 3 pi r cubed. And we're going to then sub in our equation for the nuclear radius, which is r0, that's the Fermi radius, a to the third, and we're going to cube that. Now notice the crucial bit, we are doing a to the 1 over 3 to the power of 3, which gives us an a here. So this really important bit is on the screen here is the a. When we take that ratio, we're going to notice that the a's cancel. And so we're left with an answer which does not depend on a. In other words, it does not depend on the nucleon number, which is why our answer here is C. The nuclear density does not change. It's a really good question because it shows your understanding that density is this quantity which doesn't really depend on the amount of a substance. If we have a litre of water, it's going to have the same density as a milliliter of water because we're looking at that idea of ratios, and that applies directly to the nucleus as well.